Is this the fraction when times you have to get the denominator the same, or is that not right?
You tell me.
Do you have to keep the denominator? Do you have to change the denominator to keep them the same?
That is for adding or subtracting.
Okay, so the denominator stay the same.
Right, so how do we do this one?
So it's 3 times 1, which is 3,
Mm-hmm.
4 times 5, which is 20, and that gives you a fraction of 3 over 20.
That's it. So multiplying, strangely enough, is the easy one. This one.
Is that when that's when you have to keep the denominator the same, isn't it? So, because 12's already a multiple of 3, can we keep that one the same?
Mm-hmm.
So we only have to times 1 over 3 by 4, so that would be 1 over 12 add 4 over 12.
Mm-hmm.
So that would be 5 over 12. So do you have to times 5 over 6 to get the denominators the same?
Mm-hmm.
So it would be 11 12 minus 10 over 12, which will be 1 over 12.
That's it. Top one.
What's the possible outcomes? So she gets ahead with that. So would the next one be 2 head?
Yeah.
So it would be 2 head, 3 head, 4 head, and 5 head, and then would it be going back to 1 tail, 2 tail, and 3 tail, or 4 tail, and 5 tail?
Mm-hmm.
Okay.
B.
Is it 1, 2? Is it 1 over 10?
Brilliant. Yeah, so one possibility out of 10, 1 out of 10. And the reason why there's a total of 10 possibilities is because there's 5 for this one, there's 2 for that. And so if you have to get probability, well, for both of them, it's 10.
Okay.
What that shows you is that basically if you have to find the probability of both one thing and another thing, you multiply.
Okay.
So both and you multiply. Both head and that one. This one?
A. Would it be 1, 2, 3, 4, 5, 6? So the thing would be over A, the denominator would be A, and it's asked for A. So would it be 3 over 8?
Yep. Alright, we'll do one of these.
Is it 2 over 8?
Yeah, and you don't need to simplify probabilities.
Okay.
This one?
I could take some agreement. You can have the same options. It takes a bead of bag weather. That would be a blue bead, so it would be 5 over 7, 9. It'd be 5 over 12.
Okay. This one.
Strawberry flavour sweet. Running.
Say it again.
7 out of 20.
Okay.
Does not take a lime flavour, so 11 a lime, so that would be, it'd be 9 out of 20.
Mm-hmm.
An orange sweet flavour. Would it be 1 over 20?
Why is that?
Let me just see if my line's correct. 7 over 11, that's... Oh, no, that equals 20 sweets. Would it be 0, because then when there aren't any orange flavoured sweets?
Yeah, so that's like 0 out of 20, 0. Yeah. Important one is B. The probability of lime 11 over 20 So it's 9 over 20. They add up to 20 over 20.
Okay.
Probabilities always add up to 1. And so the probability of not something, so that's lime, and so not lime, you write as lime dash, is 1 minus the probability of a lime. So that's 11 over 20. And so you do basically 20 over 20, take away 11 over 20.
Okay.
And so that's something that will always work, even for more complicated ones. If you have the probability of something, the probability of it not happening is just 1 minus that.
Okay.
Let's see this. Okay, part A.
She selects a random card. P red is 11. It's P yellow. So 11 to 5, that would make 17 over 18. No, not sorry, 16 over 18. That would be the probability of both of them.
Mm-hmm.
So that would leave, but for yellow, it would be 2 over 18, because that's what's left.
Yeah, and so it's like 18 over 18 minus that. B.
That adds blue cards to the hat, so that the property. How many blue cards does she add? Okay. Does she add? I'm not sure.
So at the moment it's 5 out of 18.
Okay.
What would it be if she added? So let's just say, what would be if she added 2 more cards, 2 more blues?
It'd be 7 of 18.
It's not about 8 out of 18 anymore.
20.
So that would be 7 out of 20. 1 out of 10 is the same as what out of 20?
2 over 20.
Okay, so it's 7 out of 20. So that's not gonna be it. So what happened? What would it be if she added 12 instead of just 2?
It would be 17 over 30.
That's never gonna get it. Amber adds blue cards to the hat. Oh, of a yellow. Sorry.
Oh, yellow. So she originally has 2 over 18. So couldn't she just add? She couldn't add 8 because if you she couldn't add 8 because if it was it'd be 10 over 26, and you can't really get that down to 1/10.
Hold on. What was the probability for yellow?
2 over 18.
Okay. And so what probability does it need to be 1 over 10?
It needs to be. So would have to be. Would you just add? Would you add 2?
Yeah.
Cards? Yeah.
Yeah, 2 blue cards. Sorry, I was looking at I thought the question was for yellow.
I was thinking you had 2 yellow cards, so
Yeah.
it's then changed to 4 over 20.
Yeah. Okay, any questions there?
No.
Okay, top one.
Would it be 0.2?
Yeah. Next one.
Table. 0.5. 0.7. Would it be 0.3?
Yeah, last one.
3, 4. 7, 5. Would it be 0.25?
Looks like it. Yep. That's it. Oh, sorry. Yeah, that's that. Yeah. Okay, I just put in the wrong answers, I think. Oh no, one wrong answer. Okay, top one.
The side of the 1, 2, 3. The spinner is biased. The probability of the spinner will land on each of the numbers 2. The probability of 1 is equal to the probability of 4, so that would mean they would be the same. So would it be 0.25?
Yeah. Next one.
Would it be 0.15.
Yeah. And last one similar, it's fine. Okay. How about this?
The probability of the pin landing up is 712 is correct. So has he simplified the fraction 3560?
Doesn't look like it.
Yeah, so what we have to do is we would put 35 over 60 and then we would have to simplify it to see if we get to 712. So,
this is part A. They should have written part A there.
sorry, is it 25 over 60?
Yeah. Over 60 and then this one. So yeah. So part B, is he correct?
Yes.
5 over 60. Divide them both by 5, is it?
Yeah.
Divide by 5. That's 7 over 12. So yes. Okay. This one.
Which roles did Jack do? So 10. Did you do it 18 times?
Yeah.
Is it 7 over 18?
Okay, this one.
Okay. Arthur rolling a 2. So the 18 over 6. 50. 18 over 50.
It's not 50.
Hold on. So 30. Oh, is it 60?
Yeah.
Do we have to simplify it or?
No.
Okay. B is on a 4-sided dice. So 22 on a 4-sided dice, and it's rolls. I'm not sure. I have a feeling you have to double it for some reason. But I just read the bit of A and it said 4-sided dice, so I'm not sure.
If you do 60 trials with a coin, what's the probability of it landing on heads?
30.
Okay, so if you roll a 4-sided dice, probability will land on a 2.
Okay. Would that just be 1 over 4?
Yeah. That's 1 over 4. What would that be as something over 60?
Would that be would that be 15?
Yeah. And what did we get for our experimental probability?
18 over 60.
And so discussion, is the dice biased?
Yes. I'm not sure. Is it yes?
I'm gonna say no, because if you flip a coin 60 times, it won't be exactly 30 and 30 in the real world.
Oh, okay.
So like if you do it for long enough, that's what's gonna happen. But it's just sometimes it's slightly more, sometimes slightly less.
Oh, okay.
So no, it's close to 15 over 60. If it was something like 1 over 60 or 59 over 60, then you'd be like, yeah, it's definitely biased. Okay, this one.
How many times did Janice spin the wheel? Did she spin it 100 times?
How many?
100 times. No, sorry. 90 times.
It's definitely much. Hang on. Oh, and Janet.
Oh yeah. Oh yeah, it is 100 times, isn't it?
100, yeah.
What was the estimated probability of green from? Would it be 72 over 100?
Mm-hmm.
How many times did Belinda spin the wheel? Belinda spun the wheel 160 times. And the estimated probability of hers for green would be 120 over 160. He spin the wheel if altogether spin 260. Where's the estimated probability? So would it be 192 over 260?
Mm-hmm.
And then F was the best estimate of green. Is it a Jenner's?
Why is that?
Sorry?
Why is that?
Because it's 28 closer to it's 28 closer to 100 than Belinda's, who's 40 away. If I'm explaining that right.
Yeah, explain it right, but it's not right. So just by looking at the diagram, it looks like green is probably 3/4.
Yeah.
However, it might not be. It might just look that way. So this one, and Jenna did it 100 times. Belinda did it 160 times. So which of those will give you the more accurate?
Would it be Belinda's?
Why is that?
Because she's done it multiple, so she'll get a better result.
Exactly. So Belinda did it more, so hers will be more accurate. And actually, the very best result will be this one, because that's a total of 260. So combining the two is actually definitely the best one.
So end results.
The sum, because most trials. Any questions there?
No.
Okay. This one.
The experimental probability of a difference is 0. Would it be not of 0? So would it be 42 over 120?
So that's 42 over 120. B.
Theoretical probability. Would it be would it be? I'm not sure.
I don't know. They wanted to draw a sample space diagram. Why did I include this question? Do we have to? It might not be worth it. All right, we better do it. 2 dice are rolled 120 times. So 2 dice. So do you know what their sample space diagram would look like?
Is it the one that starts with a circle and it splits off? Was that?
No. So I would do it as a table. So like the first dice can land on 1, 2, 3, 4, 5, or 6.
Oh, okay.
The second one can also land on 1, 2, 3, 4, 5, or 6.
Yeah, I've seen these before. And then when it meets, you have to see how many. Is it add together? I know it's different, so it'd be taken away.
Yeah.
Okay. So I'm just gonna have a quick.
I suppose where do they have a difference of 0?
Okay. So are we gonna fill in the table?
Well, yeah, but just where they have a difference of 0.
Okay. So would it be? It would be the middle, wouldn't it? So it'd be 1, 2, 3, 4, 5. It'd be 6. 6 times.
Yeah. So basically, when it's 1 and 1, 2 and 2, and so how many would be not?
So it'd be 6, 12, 18. It'd be 30.
Yes. So theoretical probability of a difference of 0.
6 over 36.
6 over 36. How many 0 differences would you predict from 120 rolls of the dice? How would you do that? Oh, 6 over 36 is the same as what?
It's the same as 1 over 6.
So I simplified that because it will make the next one easier.
So would you have to write 1 over 6 and do you have to get it to 120 as a denominator?
You could, or just 1/6 of 120.
Okay, so that'd be 120 divided by 6. That'd be 20.
Mm-hmm. And do you think the dice is biased?
No.
So that would be like 20 over 120. So 20 times out of 120. What was the experimental probability for part A?
42 over 120.
Biased or not biased?
Bias.
Yeah.
Oh,
Looks very biased. So you would expect that if it has a difference of 0 1/6 at a time, that means that you would expect out of 120 rolls, you'd expect it 20 times to have a difference of 0. It actually had a difference of 0 more than double, 42 times. And so it looks like, yeah, it's definitely biased.
okay.
And that's like more than a third of the time. Any questions about that?
Yeah, I think I need to explain the biased question again because I'm not sure how it's biased or not.
Let me just go back to the simpler one. This one. So the experimental probability was 18 out of 60.
Okay.
Theoretical probability, in theory, it's a quarter of the time, so 15 times out of 60.
Okay.
Is it biased? No. 18 out of 60 is pretty close to 15 out of 60. So it's a bit of a difference, but, it's the real world.
Okay, so the further away it is biased.
Yeah, the further away it is from the theoretical probability,
Okay.
the more likely it is that it's biased.
Do you know what the difference has to be for it to be biased or not?
So you don't. That's kind of outside the scope of like foundation, but they'll make it very obvious.
Okay.
So here, 18 is very close to 15, and then this one, 42 is more than double 20. So they'll make it obvious.
Okay.
This one, let me just see. I might just leave that. Okay, so let's do this exam question.
Okay. Tony throws the biased dice 100 times. The table shows his results. He throws the dice once more. And he gets 6. So he throws it 100 times and he'll get a 6. And his frequency. So would that be 30 over 100?
Yep.
Okay. And Emma has a bias coin. The probability that a bias coin will be 0.7. I'm just going to throw it 250 times, work out the estimate.
No, I'll leave that one. I'll come back to that one.
Okay.
So far, X a half or tick?
I think 3/4.
Okay, that's not bad. Okay, this one. So we previously filled this one in, and now we're doing part B.
Work out how many green counters are in the bag, and there are 50. So would you have to try and get 0.3 into let's see what it is as a fraction? Isn't it 1 over third, 1 over 3 as a fraction?
No, that's 0.3 recurring.
Oh, okay.
0.3?
I'm not sure. I thought 0.3, like, not recurring, was a fraction of 1/3.
Do you know 0.1?
Is that 1 over 10?
Would you know 0.7?
Is that 7/10?
And so 0.3?
3/10.
Yeah.
Okay. And it has 50 counters, so you have to get the denominator to 50, so it'd be 50. Sorry, you have to times 10 by 5 and 3 by 5 to get 15. and that gives you 15 over 50.
So what's the answer?
There are 15 green counters in the bag.
Yeah. So if we just go back a second. So this one, the probability was 1/6. So we could have done, 1 over 6 equals something over 120 and multiply it. And the way we did it though, we just did 1/6 of 120, and that gives you the thing.
And you could probably do the same for this one.
For this one, you can just do 3/10 of 50.
Okay.
And you get the same thing. And then you can go even a step more direct, and just, you don't even need to change it into a fraction. It's just 0.3 times 50. 3 times 5 is 15. Those cancel, and so it's 15.
Okay.
So it's literally just probability times number of trials. This one?
This one. Laura takes a counter and random from the bag. She looks at the colour and then it puts the counter back into the bag. She does this 50 times. Work out the estimate. A red counter. So would that be 2/10 of? That'd be 2/10 of 50. So
yeah.
So it'd be 10.
Yeah. And are you not as good at multiplying decimals? Is that why you changed it into a fraction?
Yeah.
Okay, fair enough. You got the right answer. This one?
I guess the number field landed on 2. So 0.35 as a fraction.
Just times by 100.
35.
Yes, you're not that bad at decimals.
Oh, I didn't see the
because it was an easy number.
Good.
So I think you get the idea there. I think you get the idea. They get a bit more complicated. Let me now go back to, or do I? Not yet. This one, first one, top one.
Okay, she rolls it 400 times, will land on a 5. So that would be 3/10 of 400. So would it be 120?
Yeah, bottom
one. Would it be 7/10? That's you.
Thank you.
7/10 of 300, and that would be that'd be 280. No, 210. Sorry.
Yeah. And now I'm gonna go back. Okay, part B.
Okay. So would you do 7/10 of 250?
Mm-hmm.
So that would be 25 times 7, which is hold on.
You can always divide first. So 250.
Is it 720 over? Wait, does that say 7 over 20 for B?
Sorry, it should be 10. Sorry.
So it'd be 250 divided by 10. That's 25.
Mm-hmm.
And then 25 times 10.
Not times by 10.
Oh, sorry, times by 7. Sorry. Would that be? Hold on, let me just. No, I'm not sure. I'm just gonna have to use the calculator.
All right. 25, 50, 75.
175.
Okay. 175. So basically, you're just multiplying them.
Okay. Calculator paper.
I believe. I think that was non-calc.
Okay.
25 times 7. That's not too difficult. 25, 50, 75, 100. 25, 50, 75. Okay. Part A, part 1.
So work out the probability that the student random is male. So will it be 175 over 328?
Well done.
And female going to college, so that'd be 65 over 124.
Over what, sorry?
124.
It's a student picked at random.
Oh, so it'd be the total, so it'd be 65 over 328.
Yes. Part B.
Right, what's the probability that the student is staying at sixth form? So a male staying at sixth form is 116, and because it's picked at random, it'd be over 328, so 116 over 328.
So it didn't say a student is picked at random, it says a male student is picked at random.
So would it be over 200? Would it be 200 over 240? No, 204. Sorry.
Yes. And so that's just something to watch for with these, like what it's out of. So probability from tables and stuff. X a half or tick.
I say 3/4.
Okay, that's not bad. And Venn diagrams. Okay, what goes where?
Okay, so the multiples of 3 would be put. Would be a 3 would be in the circle, and would the rest be outside the circle?
Why is 9 in the circle?
Because it's a multiple of 3.
Any other multiples of 3 in the list?
6. I don't think so. Oh, 6. 6.
And then the rest are outside. 2, 5, 7, 8, 11. Okay, slot these in.
Okay, so 10 times table. So 10 would be in the numbers. 58 would be more than 50. And so would 78. 80 would be in the middle. 30 would be in the 10 times tables. 60 would be in the middle. And 51 and 20, and 51 would be more than 50. And 28 would be outside the circles.
And if you were to summarize this down, how many are in each region?
2.
So 2.
2. And 3.
And outside?
1.
Yep. Okay. And I call this one the left region because the 10 times table is both of them, the left and the middle. More than 50 is the middle and the right. So it helps to say this is the left, this is the right, just so it's not also the middle. Okay, this one.
Phoebe chooses 53 members. Phoebe chooses a gym. So the probability of her doing yoga, would that be 18 over 53?
And do the 7 in the middle do yoga?
Yes, they do. So it'd be 25.
Yes.
Kickboxing, but not.
You're gonna be fine for the rest, I think.
Okay.
I'm not worried there. All right. No, it's just too easy. Okay, so this time you're given a blank one. You have to fill it in.
Okay. So 100 pupils in year 7 took part in various events. 70 pupils took part in track events. 20 did both track and field events. 70 did neither. So would you say in the middle would be 20? So you would because they did both, that'll leave you with 50 pupils that took part in track events, and 70 did neither. So that would be on the outside, wouldn't it? I'm not sure about the field. 200. So 60.
Yeah. Well done. So let me just uncross out those. No, you're good. This one.
So the 20 would be in the left part.
Okay.
10 would be in the middle.
So how many go to France then altogether?
30.
They said 20 went to France.
So 20. So 30 in the left centre.
Well, then it's 40 went to France.
Oh, would it be would it be 10?
Yeah.
And would the next one be and would 5?
Mm-hmm.
Okay.
So what that shows you is start from the middle and work your way out.
Okay.
You didn't get full marks.
Oh, so you have to have on the outside, so that would be 20, 25. So 15 students went to neither France or Spain.
Well done. Okay. 3 circles.
Okay. That 21 would be. I'm sorry. Middle circles. Abseiling and cycling.
Say it again, sorry?
So where it says 20 abseiling and cycling together, where the cycling and abseiling have meet together, where that so I'll explain it. So down one more. That's right.
So sailing and cycling, is it?
So abseiling and cycling.
So abseiling and cycling.
Yeah, so 20 there.
Okay, so do the people in the middle do abseiling and cycling?
No, they do abseiling, sailing, and cycling.
Okay, so if you asked them, do you do abseiling and cycling, would they say yes or no?
Sorry, say that again.
If you asked them, do you do abseiling and cycling, what would they say?
They would say yes.
Mm-hmm.
Okay. So would you say 21? Isn't it? I'm not sure.
So our rule for starting in the middle and working our way out.
Oh, okay.
So start in the very middle, then work your way out to the next middles, and so on.
Okay. So 24 and so would it be 45? Did them all together?
Sorry?
So would it be 45 because it says 21 did abseiling and cycling together, and 24 did sailing and cycling together?
So start from the very middle and work your way out.
So would 40?
Yes. So that's where we start from. So now, what is cycling and abseiling?
Would it be? Is it 7?
Yes.
And then for abseiling and sailing, would that be 10?
Yeah.
And then sailing and cycling.
Sorry, sailing and cycling. Sorry, what was that one?
For abseiling and cycling, it was 7. And for sailing and abseiling, I don't think it says.
Okay, so what can we do then?
You could work out how many people did sailing and cycling, which is 10.
Yeah, so that's 10.
Now, we can also have 6 on the outside.
Yeah, so the outside is the exception that you can always do.
Yeah. So 36 did cycling altogether. And it says, so what you've already got, you got 10, 40 and 7. So that's 30, 31. So that's only 5, so that'd be 5 there.
Mm-hmm.
6 just did abseiling. So and 38 did abseiling altogether. Okay. So sailing and abseiling be 32?
Um,
Obviously.
6.
So six,
6 just did abseiling. So what do you know about that?
so maybe 6 doing abseiling. So would that be there
Yeah.
in the? Oh, so and 38 did abseiling altogether. So so you'd have 14, 7, and 6. So that would be 27. So that leave 11,
Yeah.
and then you would add the total of 10, 14, and 11 to get 35. Who did sailing? No, you would. I'm not sure. Hold on. So there were 90. Sorry.
Mm-hmm.
So, so 10, 24, 30, 35, 40, 47. So that leaves 59 students. So 59 take away 90. That's 31.
31. So 31, 10, 5, 11, 14, 7, 6, 6. 31, 10, 5, 11, 14, 7, 6, 6. Yep. Start from the very middle, then work your way out to the next middles, and then work your way out again. One exception being the outside. Any questions there? Okay, so I'm going to actually skip for a second. Maybe you don't need to do it. No, you don't. Alright, well, I'll just throw an equation. No, you don't need to do it. I'm not going to do it. Okay, so these symbols, so the both and, this is what it looks like. So the region that's in both A and B.
Okay.
Either A or B looks like that. So that's left, middle, or right.
Okay.
And the same thing, if you ask the people in the middle, do you do A? They'd say yes, B, yes. And the complement.
Okay.
And the
Okay,
complement means not A. So A and B is like fish and chips, both A and B. A, U, B, U for union, wedding rings, left, middle, right. Complement means not A dash. If someone says you're dashing, they're giving you a compliment, and I am not dashing. There we go.
Okay.
That's how I remember. Okay, what regions are in set A?
A, L, and M.
B?
R and M.
Both A and B?
L, M, R.
No. Regions in both A and B?
Can you go back to the?
No.
I'm not sure.
Region in both A and B?
L, R. Oh no, sorry, M. M.
Yeah. Next one.
Either A or B. B. Is it M dash?
What regions are in either A or B?
Oh, L, R.
And the people in the middle, are they in either A or B?
Yes.
Yep.
Yeah.
Neither A nor B?
O.
Yeah. Not A?
Is it R dash?
Just what regions are not in A?
R and O.
Not in B?
L and O.
and neither A nor B.
Oh.
Yes. Got it. Okay, list the following sets.
So A and B. So, is it? A and B. Is it 2, 4? Is it 2, 4, and 6?
Yep. Question D.
The one with that's A or B, isn't it?
Yep.
Okay. So would that be 1, 3?
No.
Oh,
Either A or B.
so 1, 7.
A or B.
A or B. Oh, so what's in B but not in A?
That's not what I asked. What numbers are in either A or B?
Is it 3? Oh, I'm lost.
What numbers are in A?
1, 2, 3, 4, 5, 6.
What numbers are in B?
2, 4, 6, 8, 10, 12.
What numbers are in either A or B?
I'm really not getting what. I'm really not getting it.
1, 2, 3, 4, 5, or 6,
Oh.
or 8, or 10, or 12.
Is it so? It's just all the numbers that are in there.
Yeah, and you don't repeat them because they go in the middle. So if that's A, that's B. The numbers in both were 2, 4, and 6.
Yeah.
So that would be 1, 3, 5. That would be 8, 10, 12. And so A or B, union, wedding rings, everything in there. 1, 2, 3, 4, 5, 6, 8, 10, 12.
Okay.
Either A or B or both. Shade of the region.
Is it? So it'd be all of it, wouldn't it? Apart from the middle sector.
What does this symbol mean?
Is it A and B?
Right.
So all of it.
So what region is in both A and B?
Oh, the middle sector.
Yeah. This one?
A or B. So would that be A and so that'd be the left and B sector.
Okay, so the left, where else?
And the right.
Is that it?
And is it the outside?
Do the people in the middle, do they do either A or B?
Yeah. Yes.
Yeah, you're the one who keeps excluding the middle. I don't know why. I never told you to exclude the middle. This one, what is A dash?
Is that neither? That's neither A. Or is it not A?
Not A, basically. So what regions is that?
So that'd be the middle sector and no, sorry, just B. So it'd be R and O.
Not B.
That'd be L and O.
And so what am I shading for this one?
So you'd be shading R. Oh, no, you'd be shading. Oh my god. So neither R O or L O. So be not. So be M.
What does this symbol mean?
Both.
So what region is in both not A and not B?
Oh.
Yep.
Okay.
So that's the one you shade. the outside. This one.
So so A dash is not A, so it's either A or not A or B.
Mm-hmm.
So not A is the left center and the middle the left. No, sorry, the left not A would be B in the outside.
What do you mean by B?
So R and O.
Yeah, because B has two regions. Okay.
And
then B.
would that be R and M? Okay, so does that mean that means A dash or B, right?
Yeah.
Not A. So not A or B. So is it O? Is one of them O?
One of them's O.
And is the other M?
Is that it?
And sorry, say that again.
Is that it? Or are there more?
Is it R?
Correct. So it's either right or outside or the middle.
Yeah.
So that's the right, that's the outside, that's the middle, and we just don't shade the left. That's what it looks like. Okay, this one.
Okay, so A. So it would be A, but not A. Would be that'd be left and middle, and not B. Be L and O. So A or not B. So that would be L M O.
That would be union.
Oh, union. So would it be? Is it L?
Yes. So you said or, but it was actually and. But
Oh, okay.
region is in both A and not B. Okay, this one. Complete the boxes.
So would it be 2, 4, 6, 8, 10, 12?
10, 12, that's fine. And this symbol here just means everything.
Oh, okay, so
that's just literally just all the numbers there. So that's just how I'd throw that in. Okay, that's an example. Yeah, this is what I wanted. Okay, so part A.
the total the total number of students represented in the diagram 11, 7, 21. So actually because it's both, would it be 4 4 and oh, is it so I'm not, would you do 11 add 7 add 21?
Mm-hmm.
Alright, so that's 40.
I think it's 39.
39. Oh, yeah.
And so represented in the diagram, is that 39 students?
Right, so 11 and 7, that's 9. That's 18.
You forgot your 5.
Odd 5.
Me too, do need that. So that's 44, I think.
Yeah.
B.
So P and so B, is it just what's in F?
Right.
So 18.
And P is for probability.
Oh, probability 18 over 44.
C.
Is that's should be over 44.
Mm-hmm.
So the probability of it being F or S, would that be 38?
I believe it was 39.
39, sorry.
And D.
probability of not being not being F, sorry. So, is it 21? No, sorry, 26 over 44.
Brilliant. Well done. So that's using those things. 26. That looks similar. Let me just see. Okay, we'll go exam question.
So the total is 9, 14, 22, 30. So total is 32.
Mm-hmm.
A would be the probability of X and Y. So that would be 29 over 32.
What does that symbol in the middle mean?
Both.
Mm-hmm.
So it'd be both X and Y.
Mm-hmm.
So wouldn't it be 7 and 10 and 12?
That would be either X or Y. You're thinking of the wedding rings? The union?
Oh, 10.
Yeah, this is both and fish and chips. And B?
So it'd be neither X or Y. So would it be 3 over 32?
You're skipping stuff. X dash.
So 12 and 3.
Yeah. Y dash.
Y dash 7 and 3. 7 and 3.
And so this one then?
So 7 and 3, 10, 12 and 3, 15.
Sorry, I should have put a comma in between those.
Oh.
Or maybe I should have done like right and outside or something, would have been better. Yeah. So X dash right outside. That one is left and outside. Okay. And so B?
So would it be, the probability would be over, so would that be, is it, 10, is it, 22 over 32?
So it's going to be the left and the right and the outside over 32. Yeah, so that is 22 over 32. So that's Venn diagrams, X a half or tick.
I say a half.
Okay. So then the only thing we didn't get onto was the tree diagrams. If you want, we can do that next time or something else.
Yeah, we can continue on with this.
We're nearly we that's the only thing we had to do anyway. Any questions for me in general?
No.
Okay. Well done, Noel. You did great. I look forward to chatting again next time.
You too.
Have a good one. Goodbye.
Bye.